Hi, so in this video we are going to be looking at a problem statement which is nothing but count the number of inversions in a particular given array. And it's not given that the array is going to be sorted or not sorted, right? It might be sorted and it might be the case that it's totally scrambled. Well, what really is an inversion? So consider the indices of the array, so that's 0, 1, 2, 4 and 5, right? So 0, 1, 2, 3, 4 and 5. What is the condition for the inversion to occur, right? So we are going to look at it. So consider two indices I and j. So for any two indices or a pair of indices I comma j, if this condition holds, what is the condition? I'm going to write it. So if I is less than j and my a of j is less than a of I, right? So in this case, the inversion is going to occur. So this is the condition for inversion. So what that really means? Now consider two indices, just for an example purpose. Consider two indices, for example, 0 and 3. So my I is 0 and my j is 3, right? And what is my a of I? So a of I is 2 and a of j, which is nothing but 3. So a of 3 is nothing but 1, right? Now you can see the following condition holds. How? So you can see that 0 is less than 3 and a of I, which is 2, is actually, so let's just write the a of j first. So actually 1 is less than a of I, which is 2. And this is the condition for inversion we just saw, right? So how do we deal with this, right? We have to count the number of inversions in the array. Let's just try run the code like quickly, right? So you can see here that here is an inversion. So 2 and 1 is in one inversion. So the count will be like this. Count is nothing but 1 as of now. So 2 and 1 is an inversion, I believe. So this is only it. 3 and 1 is an inversion, right? So that's plus 1 more. 4 and 1 is an inversion. So that's 1 more. Let's see others. 4 and 6, 4 and 5, no, that's not an issue. 1 and 6, 1 and 5, no, again, that's not an issue. 6 and 5, right? So 6 and 5 is an inversion because 6 is, in fact, 4 is less than 5 in terms of indices, but 6 is greater than 5, right? So that's an inversion condition. So that's 1. I believe so 4 is the total count of inversions in this example. So let me just go through it. So 2 and 1, 3 and 1, 4 and 1. So that's 3 and then 6 and 5 and that's 1, right? So let's just see what will be the brute force approach, right? And brute force approach is nothing but a naive approach which strikes our mind whenever we see a problem statement. So the brute force approach will have a time complexity of big O of n square. Why is it happening, right? So you can see here that a naive approach would be as simple as picking one element, right? Picking one element or setting one element. For example, I am at element 2, right? And traversing through the entire array. So I'm going to traverse through the entire array and find inversions for the current element, which is 2. And then I'm going to pick 3, right, which is my next element. And then I'm going to traverse this part of the array. And then what I'm going to do is I'm going to pick 4. And then I'm going to traverse this part of the array. So at max, in the worst case, what is the time complexity? Let's see. We can see the length of the array is n. So when we are traversing, we are actually traversing the entire array, right? Up till, in fact, 4. So we are kind of having n into, in the worst case, we have to traverse n minus 1 times, right? Basically, we won't traverse the element which is right here, right? So for example, I won't be traversing backwards. For example, if I'm starting at 4, I won't be traversing 2 and 3. I'll be only traversing 1, 6 and 5, right? So in the worst case, this will be n into n minus 1. So that's n square. I believe so, minus n, and this should be big O of n square, right? And I hope that makes sense. So a rough pseudocode would look like this. So for I in range n, right? So basically I'm going to be writing the code in Python because there are many languages I could have like selected, right? So Java, C++, C or Python, right? So because I'm writing in Python, you can kind of, I believe you are all smart enough to kind of convert the Python's pseudocode kind of version into your own language. So for I in range n basically traverses the array till the very end. And to be more frankly, this should be simply n minus 1, right? I should not travel till the end, because I won't find any inversion at the end of the array, right? So let's just see. So this is going to be for I in range n minus 1, and then for j in range, and what this should be, right? Let's see. So up here you can see that I have to traverse from I plus 1. Why so? Let's see. So in this example, right, if you pick 4, right, if you pick maybe like 4, right, if you pick 4, so you won't be traversing from 4 till 5, right? You have to traverse from 1 till 5. It's no point checking with the same element, because that's not what the condition says. It says that you have to pick 2 pairs of indices which are different, right? So you will be accessing from 4 plus 1, so that's 2 plus 1, so that's I'm going to be accessing from 3 till the very end. So this is going to be looking like for j in range as simple as I plus 1 till the very end, which is n, right? So this is going to be the condition. Now I'm just going to simply use if statement here, right? So if my I is less than j and a of basically j is less than a of I, right? Well, in all the cases my I will be less than j, so there is no point checking this, but I'm writing that just to make sure that we are on the right page, right? We are checking for inversions, and this is the main condition of inversion. So I'm going to check that if I is less than j and a of j is less than a of I, then my inversion count. So for example, I have written one variable inv count, just writing in it short, so that's inversion count. So I'll just write inversion count, I'll just increment it by 1, right? And at the end I'll just print this, right? I'll just print this stuff, this will be printed, and that's not an issue. And because we are looping twice in the array, that's why we have a time complexity of big O of n square. But can we do further? Like, can we do best apart from this? Well, the interesting fact is, yes, we can. And we are going to be using the concept of sort, right? So the best sorting method we can have uses n log n time complexity. It comes from quicksort and merge sort. Well, we are going to be using merge sort. And the way we merge the arrays, right, or the way we merge the small blocks of elements kind of will help us in finding the inversion. Let's see how. So I'm just going to take the same example. So that's 2, 3, 4, 1, 6, 5, right? You have to bear with me if you want to understand the concept very well. So that's 2, 3, 4, I believe that should be 1, 6 and 5. Excuse me. So I'm just going to run over the basic pseudocode of merge sort, right, or the working. So we are going to be splitting the array into 2 parts, right? We are going to be splitting the array into 2 parts. How we are going to do that? Let's see. I believe so this 3 might be a little here and there. So yeah, that's good. So 2, 3, 4, 1, 6, 5. We can see that we can split the array equally, right? So I'll just split the array equally. So that's 2, 3 and 4. I hope that makes sense, right? And then up here we can write 1, 6 and 5. Right? And if you don't remember, then merge sort is a divide and conquer technique, where we divide the array into subparts, kind of conquer them and win over that, right? You can kind of think of it like that. So 2, 3, 4, 1, 6, 5. Can we divide it further? Definitely. What is the base case in merge sort? Let's see. For example, if I don't know the base case, then how do we know? Let's see. So I can kind of split 2 and 3 and 4, right? So we can write it like this, 2. And then I can split it into 3, 4. Right? For 1, 6 and 5, I can split it like 1. For 6 and 5, this should be, for example, 6 and 5. Can we split further? For 2, no, we cannot. So I can see that the base case here is, I'm just going to writing in small letters. So the base case is when the length of the block, right? So the length of the block is actually 1, right? The length of the block is actually 1, and that's the base case. So I'm glad that we have come up with the base case, right? Can we split 3 and 4 further? Let's see. So for 3 and 4, we can have 3 up here and then 4 up here. Again, that's the base case, right? For 1, no, that matches the base case. 6 and 5 never matches the base case. So I'll just write 6 and 5. And this is the entire splitting part of the merge sort, right? And when I'm going to I'll just write the code here, right? The code. I'll just show step by step what I'm doing, right? So let's just see how it's going to help. Well, after we have split the array, right? After we have split the array into in a good diagrammatic way, we are going to combine it, and when we combine it, we are going to sort it in place, right? So we can see that in the left part, right? So this is the left part L, and this is the right part R. So we are going to be checking that if the left part is greater than right part, then I'll swap it, right? If that makes sense. So for example, if the left part was 4 and this was 3, then I'll just swap it, right? But in this case, the left part is smaller than right part, so I don't have to do anything, right? And there is no inversion in here as well, right? There is no inversion. When is the inversion going to occur? The inversion is going to occur when my right part, right? So my right part is smaller than the left part, right? Because when I'm splitting the array, the order of the elements is maintained. You can see at the leaf nodes, right? At the leaf nodes, we have the order of the array. So 2, 3, 4, 1, 6, 5. 2, 3, 4, 1, 6, 5. So even if up here I find any element on the right side which is smaller than the element on the left side, it means that in the array, the element will be smaller than the left side, right? So it means that there is an inversion. But as of now, we can see that there is no inversion. So I'm just going to rub this up quickly and let's proceed, right? So up here, I can see that my condition satisfies that left part is less than the right part. So this is kind of okay. Again, I'll compare here, right? Again, I'll compare here one by one. So is 2 less than 3? Yes, it is. So I can just simply kind of merge these two and write it up here. So that's 2, 3, and 4. And there is no inversion in this block, right? There is 0 inversions in this block. You can even see here that up till part of this array, right? 2, 3, and 4, there are no inversions. Yeah. So let's just move to the right hand part, right? So my left hand part has been done. And what is the answer from the left hand part? It's 0, right? For the inversion count. Let's check the right hand part. So I'm just going to write it quickly. So that's left and the right part. Now you can see that the right part is actually smaller than the left part, right? Even up here, the right part is smaller than the left part, right? Or the right number 5 is less than the 6, right? And I is also less than j, because up here you can see that 0, 1, 2, 3, 4, 5, right? So index was 4 and 5. 4 is less than 5, but 5 is less than 6, or 6 is greater than 5. So that's an inversion condition, right? So from here, my updated array, when I'm merging it, should be 5 and 6, right? I'm just going to write 5 and 6, right? Because this is the updated merge sort thing, right? And what is the answer from this block? My answer from this block for inversion count is 1, right? So 5 and 6, there is only one inversion. Even if you consider this small block, how many inversions are there? We can see that there is only one inversion in that small block. So I hope that makes clear. So from this part of the array, we have one inversion. Now, this is the updated part. Have we updated this one? No. Now we have to merge these two and write the answer here. Let's see. So I'm going to consider 1 and 5. Is 1 less than 5? Definitely. So if 1 is less than 5, then 1 is less than any elements which occur after 5, right? So for example, 1 is less than 5 and 6 because this is sorted. That's the beauty of it. That's the beauty of merge sort. So again, I merge these two. So this should be 1, 5 and 6. This should be 1, 5 and 6, right? Now comes the main part. So I can see here that, we'll just write it quickly. So I'll just going to draw it somewhere else. So 2, 3 and 4, right? At the final stage, we have 2, 3 and 4 and 1, 5 and 6. So 2, 3 and 4. And then we have 1, 5 and 6. We have 1, 5 and 6, right? And what is the answer from this part? The answer from this part was, I believe so, 0. And the answer from this part, or the right hand side of the part, was 1, right? For the inversion count. Now I'm going to merge these two and write the whatever the thing is, right? Whatever the thing is. So let's see. We are going to be comparing elements one by one. Now pay attention. 2 and 1 we are going to be comparing here. So I can see that is 2 less than 1? Let's see, is 2 less than 1? No, that is not the condition. So there is an inversion, right? There is an inversion. There's a big inversion here. So how do I compute that? Well, you can see that if 1, or the element on the right hand side, is less than any element, or any element in the left hand side, right? Then it's going to be less than every element after it, right? So for example, every element after it should be 3 and 4. And that's the beauty of merge sort, because the array at each and every step gets sorted, right? So 1 is going to be less than 2 definitely, and it's also going to be less than every element which occurs after 2. So how do I compute it? For example, a naive approach would be to compute it like this. Is 1 less than 2? Then answer plus equal to 1. So answer plus plus. Is 1 less than 3? Answer plus plus once more. Is 1 less than 4? Answer plus plus once more. So it's going to take time, right? So I want to avoid that kind of scenario. So it's better to do that. Answer should be incremented by the length of the left part, right? So the length of the left part minus the index where I am at. So that's the 0. I'm at the 0th index. So what is the length of the left part? Which is 3. So how many inversions are there? 1 is an inversion to 2, 1 is an inversion to 3, 1 is an inversion to 4. So my inversion count with respect to 1 is 3. I hope that makes sense. So this is going to be nothing but when it's going to be combined here. So this is going to be 1, 2, 3, 4, 5, 6 when it's going to be combined, right? So it's not, I'm not able to write it here. Yeah. So I hope that makes sense. And this is going to be what the array is going to look like, right? So this is how the entire working will be, right? And what was our original answer? Let's see. Our original answer was basically, let's see. So it's going to be, that's 1 inversion, that's 2, that's 3, that's 4. Yeah. So the answer is 4. So on the left hand part, I got 3, and on the right hand part, I got 1, and I merged these two answers. So that's 4. And I hope that makes sense. Let's just try to code it, right? And when I'm going to code it, I'm going to be explaining it properly, right? So let's just try to code this. I'm just going to be declaring it like, right? So if name is equal to name, then let's just take an example of array. For example, 2, 3, 4, 1, 6, 5, right? So it's 2, 3, 4, 1, 6, and 5. I wrote it 67. That's not an issue. And let's call a function like merge sort, right? We'll just call a function like merge sort, and we are going to be defining one variable which is going to be global, right? So let's just define it. So that's global inversion. Let's just define it as global maybe count inversion. I hope that makes sense. So I'm going to be initializing it here. So global count inversion is equal to 0 at the beginning. And merge sort, what I'm going to pass here, right? I'm just going to pass the array, as simple as that. And at the end up here, I'm going to print that the total count of inversions in the array is, and then I'm going to print count inversion. Now I'm going to define the function, or the user defined function merge sort, right? Or I can even write it as merge sort underscore inversion, because I'm not only sorting the array but also counting the inversion side by side, right? So define merge sort underscore, I think I messed up the spelling, so inversion, and then I have my array here, as simple as that, right? A. Let's just take it as ARRAY array. So it makes sense. Now what we are going to be doing, let's just see. So basically we are going to be defining the base case first, right? So what was our base case? So I'm just going to write base case, right? What was our base case? Well, the base case is simply that if my length, I think I should be defining the conditions first, or maybe the statements first, or the comments, then I'll just try to explain the code. So firstly, we are going to be defining the base case, then maybe we can compute the mid, right? And what is mid here? So mid is nothing but the middle index of the current array I am at, right? So where I am at, right? So the compute mid is nothing but the middle index of the current array I am at, whether it be the left array or the right array or the entire array, right? And that's going to be taken care of. Then I'm going to be computing the left sub array and the right sub array. And what is that? Let's see. So the left sub array is as simple as this part, and the right sub array is as simple as that part. And recursively, at the end of the day, this is the left part, right part, left part, right part, and then so on, right? So we are going to be computing the left subarray and the right subarray, and I hope that makes sense. Now we are going to be simply recursively calling the left and the right halves. And how do we do that? As simple as recursion, right? So I'm just going to recursively call the left and the right halves, right? And I hope I've not messed up the spelling of halves here. And that's it, right? So this was the above part is the splitting part or the dividing part, because as we know, the Mergesort is a divide and conquer technique. So this is the dividing part, right? And we have finished that, right? And we are done with it. That's it, right? That's it. Now, right? So now we are going to begin with the merge part, right? We are going to be beginning with merge part and also compute the inversion side by side, and that also is an important point to notice. So let's just define the base case here. So what will be the base case? If my length of array, right, is equal to 1, or you can even write it like less than equal to 1, but that won't really make sense. So equal to 1, then what I'm going to do? What should I do? Well, simply I can just do is return, simply return, right? And also I believe so we have to define the count inversion once again. So that's global count inversion. I define it to just to make sure that I'm on the right page. If you don't define it right here, it's not a problem because you have defined it up here, right? As I declared it in the beginning, right? I just do that just to make sure that yes, I'm dealing with this variable, right? Because I kind of forget about it. Okay. Compute mid, right? So how do we compute mid of any index of left and right indices? So consider this was an array of some elements, right? So what is my first index here? So my first index is 0 and my last index is nothing but n minus 1. And what is n minus 1? N is basically 7 here, so 7 minus 1 is 6. So my first index is 0 and last index is 6. So what will be my middle element here? I can see the middle element should be 4, round about 4. So how do we do that? We simply do 0 plus 6, which is nothing but the first index and the last index, by 2. So how much this should be? This should be 3. Let's see. So my third index will be falling at 0, 1, 2 and 3, which is nothing but 4. And I find the correct middle index. So how do we do that? It is simply going to write mid is equal to basically length of the array, right? Length of the array by 2. And I hope that makes sense, right? I'm just simply getting the length of the array and I'm dividing it by 2, right? Now, what's the part? Computing the left subarray and the right subarray. Let's do that. So I'm just going to write it completely. So left subarray is equal to array, and how I'm going to write it, right? So let's just go over it. I'm just going to simply delete this whole part. So if this is my, okay, I believe so, I'll just write it properly. Yeah. So if this is my element array, right? So for example, 11, 10, 9, and maybe one more, 10, 3, 2. So that's 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Yeah. So my middle element will be 0 plus 6, or more properly 7 by 2, length of the array by 2, which is 3. This is an integer division in Python. That's what I wrote here, as you can see here, right? Now, how do I split it, right? There can be several criteria. Well, the simple criteria is my left part will be start of the array till mid, but excluding mid, right? Till mid, but excluding mid. Exclude mid, as simple as that, exclude mid. And what will be my right part? Well, my right part will be starting from mid till the end and include mid, because if I don't include mid in the left part or the right part, then that element is missing out, right? And it might be an error in the answer. So include mid in the right part, but exclude mid in the left part. Many might confuse that till mid, so I will also take mid, but no, we have to exclude mid in the left part, and the right part we are simply including the mid. So how do we do that? We're going to be doing it like this. So array from start, so my start index is 0 till mid. right? So if I write mid, then in Python, there is a property that if I write something on the right hand side part, it's going to be taking till mid minus 1 inclusive of that, right? And even if I don't write 0 here, it's going to be fine. But just for understanding purpose, I'm going to be writing 0, right? And then up here, we can compute the right sub array. So that's right sub array, right? Array of starting from mid till the very end, right? So if I'm not giving any value here, right, the one which I've highlighted, then it means that it's going to be taking the entire thing, right? Now, what is this next part? It's saying that recursively call the left and the right halves or the sub arrays, right? It's the same thing. So how do we do that? We just simply remember the name of the function, right? So this was the name of a function. I'll just copy it. So it's going to be looking like this. So I'm going to be calling the left part first and then the right part. So are we going to passing array here? No, we are going to be passing left sub array and then we are going to be passing right sub array. And I hope that makes sense. And that's what the statement or the comment says here. Recursively call the left and the right halves or the sub arrays. Now it's saying that the above part is the splitting part or the dividing part, and we are done with it. And I'm very glad that we finished that, right? Now let's see the concur part, right? So now we are going to begin with the merge part and also compute the inversion side by side. Or this is also the concur part of the divide and conquer technique. And what is the divide and conquer technique? It's Mergesort. So how do we do that? Well, for the left sub array, I am going to maintain one index I, right? So this is for the left sub array. And for the right sub array, right? For the right sub array, I'm going to be maintaining an index called j. And I hope that makes sense. So for the right sub array, I'm going to be maintaining one index called j. So that's j is equal to 0. Now, do I need to maintain any other index? Yes, we do need to. Why? Because look, when we are computing the left and right sub arrays, right? So just going to delete it here. Yeah. So this was some array and this was split into some smaller part, right? And so my I will be pointing to somewhat starting to the left sub array and my j will be pointing to somewhat to the right sub array. So this is the left part, this is the right part. Now I'm going to be kind of sorting this in place, right? Definitely this is taking approximately big of n space, extra space, but the time complexity will be n log n, and that's not an issue. But I'm just saying that if we are sorting it in place, right, we are not requiring any other array. That's a wastage of memory or the space complexity thing. So I and j are pointing to the left and right. So definitely for the main array, I'll be maybe considering one index called x or z or k, whatever you may call it, right? So I'm just going to write it as left here just to make sure you all don't confuse. So that's right. And now maybe like for the main array, I'm going to be maintaining one index called main array, right? And this was right and this was left, right? So for main array, how do we do that? We just simply write main array, and these are nothing but the indices. Now what do we do now? Now we kind of in place sort by using if condition and I hope that makes sense. So how do we do that? We are going to be simply using maybe while loop, right? So we are going to check that while my left index is less than the length of the left sub array, right? And my right is less than the length of the right sub array, right? And I hope that makes sense. So how do I compare it, right? If you remember from the explanation, it's as simple as that if my left sub array or if my left sub array element at the left index, right? So if the element in the left sub array at the left index is actually less than equal to the element in the right sub array at the right index, then will there be an inversion? No, definitely. No inversion occurs here. Happy, right? We are happy that there is no inversion here. Excuse me. So how do I update it in the main array? Well, it's as simple as my main array is array, and what is the index of main array? So it's main array, as simple as that, should be left sub array of left. And what do I need to do now? Well, I can do is I have to increment the left pointer by 1, right? Because I'm going to be moving in the left sub array, and also I'm going to be incrementing my pointer in the main array. If the above condition does not satisfy, right? So if this condition does not satisfy, it means that my the element in the right sub array is less than the element in the left sub array. Then in this case, inversion occurs. So I'm kind of sad, right? Because inversion is nothing but, at the end of the day, it's nothing but the degree of, the degree up to which, or the extent up to which the array is not sorted, right? You can kind of conclude it in that way, okay? So inversion occurs. Now, what do we do? Well, we can simply write array of k at first. So maybe k or maybe main array, right, is going to be nothing but the right sub array, right? So the right sub array. And what is going to be the index here? It's nothing but right, because I'm accessing the right sub array, right? Now, my right index in the right sub array will be incremented by 1, and I hope that makes sense. My main array will also be incremented by 1, and here comes the inversion count, right? So how do we define the variable? Count inversion, right? Count inversion. So how do we write that? We are just going to be simply writing count inversion plus equal to, or maybe I'll just write count inversion is equal to count inversion plus, what was the formula which I mentioned in the explanation? It's nothing but the length of the left sub array, right, minus the current index I'm at in the left sub array. So that's left, right? I'm not writing it as I or j, which you might find in various explanations on Geeks or Geeks, maybe any other resources. I'm just using left because it makes sense, right? So left is pointing to the left sub array, right is pointing to the right sub array, and this index is pointing to the main array, right? So, and I hope this makes sense. So count inversion is like this, and you can kind of see one small optimization or neat code optimization you can do here is you can kind of take this main array plus equal to 1 out, and then you can write it up here. So what I'm talking about is you can just simply write main array plus equal to 1, because whatever the case may be, I'm doing it twice here, right? So that kind of counts for a bad code representation, right? I want to write a clean code, and I hope that makes sense. So is my process done here? No, it's not done here. Why? Let's see. So I think I missed my doodle pen here. Yeah, it's here. So consider my left and right sub array were like this, right? So my left and right sub array had elements like this, right? So 1, 2, 3, 1, 2, 3. My left is here and my right is here. At the end of the day, right? At the end of the day, all of the elements will be traversed. That's not an issue. But what if the left sub array has 3 elements, right? This is the left sub array, and my right sub array has more than 3 elements, right? It can be more than that. So up till the first 3 elements, my array will be accessed, and this part will be missing out. So how do we do that? As simple as that. So what we are going to do is simply write it like this. So pushing all the leftover values from the left sub array into the main array, right? So it's as simple as that. So while left is less than length of the left sub array, right? So it's less than the length of this left sub array. Then what I'm going to do is that in the main array, so array, and the index is main array, is going to be left sub array, and the index is nothing but left, and I'm going to be incrementing the pointers. So left plus equal to 1, and then my main array pointer will also be incremented. So main array plus equal to 1, and I'm going to be doing the same for the right sub array, right? Control C, and I'll just copy paste it here. So hope that makes sense. So pushing all the leftover values from the right sub array into the main array. And how do we do that? As simple as that. So while right is less than the length of the right subarray, right? Then in the array, I'm going to be accessing the array elements as main array because that's my index. It's going to be right subarray of the right index, and I'm going to be incrementing right by 1 and then main array by 1, right? As simple as that. I think we should do a code review here because we have written a lot of comments. So let's just see. Let's just try to run. If that fails, then it's definitely a time to code review. So I'm just going to write Python inversion underscore count dot py, right? The total count of inversions in the array is 4, and I hope the video is being recorded because once I was recording one video and it passed 30 or 40 minutes and I realized that the video was not recording. So that's an issue. So you can see that the total count of inversions in the array is 4, and that's something which we derived it, right? Or we kind of saw from the example. Let's just take one random array, and by random I mean really a random array, right? Just write some elements here, maybe 10, 100, 1, 2, 3, 4, 5. Let's just see. So how many inversions are here? 10 and 100? No, that's not an inversion. I'll just write 100 properly. So 10 and 100, right? That's 1, 2, 3, 4, and 5. I hope that makes sense. So 10 and 100 is not an inversion. 10, 1 is an inversion. 10, 2 is an inversion. 10, 3, 10, 4, 10, 5. So how many are there? So that's 1, 2, 3, 4, and 5. So up till now, count of inversion is basically 5 for 10. For 100, it's going to be 1, 2, 3, 4, 5. So that's 5 more. For 1, it's going to be 2, 3, 4. No. So I think 1 is going to be having 0 inversions because 2, 3, 4, and 5 all are greater than 1. Again, 2, 3, 4, and 5 will have 0 inversions. So I think the answer should be 10. Let's just see. So 10, 100, 1, 2, 3, 4, and 5. This should be 10, 100, 1, 2, 3. I hope this answer gets wrong so that I can learn something from this topic. Let's just see. So this is going to be the total count of inversions in the array is 10. And I think that concludes the count of inversion part. And also the time complexity of this is nothing but time complexity TC is big O of n log n. And the space complexity is close to big O of n because in the left and right subarray, we are going to be storing some half of the array, right? So this is, for example, n by 2 and this is n by 2. If you add them up, that's n, right? At the end of the day, even if you add all of them up, so that's nearly big O of n space complexity, extra space complexity, right? And the time is big O of n log n because we all know that merge sort and quick sort are one of those efficient sorting algorithms which we use, right? And I hope the video makes sense, and I hope I was able to clearly explain the internal working of how the inversion part works, right? So maybe we can meet in the next video. Thank you.